In this video we look at how to calculate the mean value of a function over an interval. So let's consider the problem of finding the mean value of x squared over the interval of values of x going from 1 up to but not including 6. Well, we could just consider the 5 possible integer values of x. So we've got x could be 1, 2, 3, 4 and 5, with x squared being 1, 4, 9, 16 and 25. And if we do that, then the average value of x squared is going to be 1 plus 4 plus 9 plus 16 plus 25 divided by 5, which gives us 11. Now let's have a look what we're doing graphically at this stage. So we know what the graph of y equals x squared looks like. And then if we think about what's going on, then the rectangles I've got a rectangle from 1 to 2 with height 1. So that's got an area of 1. I've got a rectangle from 2 to 3 with height 4. So that's got an area of 4. I've got a rectangle with running from 3 to 4 with a height of 9. So that's got an area of 9. I've got a rectangle running from 4 to 5 with a height of 16. So that's got an area of 16. And I've got a rectangle running from 5 to 6 with a height of 25. So that's got an area of 25. So we can interpret that calculation that we've got as being the area of the rectangles divided by 5. Now, the issue here, of course, is that we've only considered a few x values. We really ought to be considering far more than just the 5 integer values of x. So let's instead take values of x every 0.1. So our table of values is going to be much larger. So we've got values of x going 1, 1.1, 1.2, and the value of x squared is going 1, 1.2, 1.44. And our final value of x is going to be at 5.9, and that is going to have a value of x squared of 34.81. So the mean of these values is going to be 1 squared plus 1.1 squared plus 1.2 squared all the way along to 5.9 squared, divided by 50 because we've got 50 values. So the mean value is 699.25 divided by 50, which gives me 13.985. Now, let's have a look at the little rectangles we've got. The first little rectangle has a base of 0.1 and a height of 1. So its area is 1 times by a tenth. The second rectangle has a base of 1/10 and a height of 1.21, so that is going to have an area of 1.21 times by a tenth and so on. So how can we look at this then? We've got 1 squared plus 1.1 squared plus 1.2 squared all the way up to 5.9 squared divided by 50, and we can say that that is 1 squared plus 1.1 squared plus 1.2 squared all the way along to 5.9 squared times by 0.1 divided by 5. And the 1 squared times 0.1 is the area of the first rectangle. The 1.1 squared times the 0.1 is the area of the second rectangle. The 1.2 squared times by 0.1 is the area of the third rectangle. The 5.9 squared times the 0.1 is the area of the final rectangle. So what I've got there is I've got the area of all of the rectangles divided by 5. Now, taking more and more evenly spaced x values, the area of the rectangles calculation will get closer and closer to the area under the curve, which is the integral between 1 and 6 of x squared, or 71.66. So the mean value of x squared over the interval 1 to 6 will be 71.666 divided by 5, in other words 14.33. So let's now try to generalize our result and find the mean value of f of x over the interval a to b. What we're going to do is we're going to split the interval between a and b into n equal sized parts. x1 is going to be the x value at the start. x2 is going to be the x value at the left hand end of the second rectangle. x3 is going to be the x value at the left hand end of the third rectangle. x4 is going to be the x value at the left hand end of the fourth rectangle. xn is going to be the x value at the left hand end of the nth rectangle. Our estimate then for the mean value would be f of x1 plus f of x2 all the way up to f of xn divided by n. If we let delta x be the width of each rectangle, then we've got n times delta x must equal b minus a. So n is the same thing as b minus a divided by delta x. So we've got the estimate of the mean is f of x1 plus f of x2 all the way up to f of xn divided by n, where n is b minus a over delta x. Which means that the estimate of the mean is f of x1 plus f of x2 all the way along to f of xn. Rather than dividing by b minus a over delta x, we're now timesing by delta x over b minus a, which of course is 1 over b minus a times by the sum between the x equals a and x equals b of the f of x values times by delta x. To improve the accuracy of this estimate, we just need to have more x values, so we need to increase the size of n. In other words, we need to decrease the size of delta x. So to get a really accurate value, what we need to say is that the mean value is the limit as delta x tends to 0 of 1 over b minus a times by the sum of the f of x's times the delta x's. The 1 over b minus a is a constant, so that can be pulled outside the limit. So we've got 1 over b minus a times the limit as delta x tends to 0 of the sum of the f of x's times the delta x's. And a couple of videos ago we saw that this sort of limit is precisely an integral. So we've got the mean value is 1 over b minus a times by the integral between a and b of f of x dx. And that is the important result for this video. So, mean value of f of x over an interval a, b is given by 1 over b minus a times the integral between a and b of f. So, to find the mean value of 12e to the minus 2x over the interval between minus 1 and 12, then, applying the formula, we've got the mean value is 1 over 2 minus minus 1 times by the integral between minus 1 and 2 of 12e to the minus 2x. So that's 1/3 times by the value of minus 6e to the minus 2x when x is 2 minus the value of minus 6e to the minus 2x when x is minus 1. So that's 1/3 of minus 6e to the minus 4, take away minus 6e squared. In other words, we've got 2 lots of e squared minus e to the minus 4, which gives me an answer of approximately 14.74. Now it's just worth spending a little time just interpreting the mean value and what it actually means geometrically. We could rewrite the formula, the mean value equals 1 over b minus a times the integral between a and b of f, into b minus a times by the mean value equals the integral between a and b of f. So for a positive function, the value under the graph of f of x between x equals a and x equals b is the integral between a and b of f, and that is exactly the same thing as b minus a times m, which is the area of the rectangle with vertices a0, b0, bm and am. In terms of the function that we looked at in example 1, the red graph gives me the curve y equals 12e to the minus 2x, and in the pink, light pink shading, you can see the area underneath that graph between minus 1 and 2. The purple line gives us the value of the mean value, and the area underneath the mean value, underneath that line, or the area of the rectangle formed by minus 1, 0, 2, 0, 2m and minus 1m is the lightly shaded purple area, and the area of that rectangle is 44.22. So the area of the rectangle is the same as the area underneath the curve. So we've looked at how to calculate the mean value of a function f over an interval a to b, and it is simply the evaluation of 1 over b minus a times by the integral between a and b of the function.